I've been with Star Irrigation. We're out of Dallas, Fort Worth. We service all of DFW. Talking about well pumps today real quick, just kind of how low capacity works. A lot of well situations where you have heads that are not coming out of the ground. Runs good at first, runs through a couple zones. The zones after that, about 30 minutes, really don't have anything left. So we're going to talk about a little bit about how that works and just the philosophy of pumps here, of well pumps and expansion tanks. So real quick, if you're familiar with an air compressor, very similar to that. So this has to do with zone design, friction loss, volume of flow, so understanding pressure and understanding volume. Pressure is like the amount of force, volume is the capacity, and obviously hence the word volume. So what we've got here, we have a well pump outside in the ground that is a submersible pump that probably producing around 10 gallons a minute. So remember that number, 10 gallons a minute, right? That's most well pumps. There are some that do greater or less, but generally speaking, you're going to be at a 10 gallon a minute. So what that means for us, if every zone designed for 10 gallons a minute, you really don't need this system. We have to, but that's just not going to happen with irrigation design. You're going to have some to do 7, some to do 9, and then in a lot of situations you'll have to do 12, 13, 15, whatever the case may be. So we're going to talk about why that works. So we have here the expansion tank that works like your air compressor. Water is not compressible. So this has like basically a spring mechanism of some kind in here. I'm not real familiar with the internals of these, but this is what creates that pressure. We have our water coming in and water coming back out. So they're in and outs basically through the same pipe. In this situation, a lot of times they'll be separate. So basically what happens here is your water's going to come in and effectively go straight out, but it's being fed by this amount of pressure. So that's how this one's designed. A lot of times, like I said, you'll have it into the tank and then maybe it'll come in this side, go out that side. This one's set up, both work, either way. So we've got our pressure gauge. Right now our system is not running. We're sitting here at about 56 PSI or so. And then this is our pressure switch. So what this does, again, this works just like an air compressor. Our pump is off when we start the system. It's a 40-60. What'll happen is as soon as you start a zone, it starts to use that pressure that this is supplying. Your pump will not be running. Your rotors are coming up, the spray heads, whatever. Your system starts to run. And once this gauge gets down to 40 PSI, where we only have that much pressure left, then it signals this to kick on. So, or this has an internal gauge doing the same thing. It's just for you to read. And this will kick on, which turns the pump in here. This sends power to the pump. So now we're running the pump in the ground, putting out 10 gallons a minute. Let's say, for instance, we're running a zone at 8 gallons a minute, right? What'll happen is this runs down to 40, the pump kicks on, but that pump only ever puts out 10 gallons a minute. That's the purpose of this, is so that we can run variable gallons per minute zones, or running a faucet inside that's only doing a half a gallon a minute. Never have to worry about overworking, underworking, deadheading the pump, anything like that. It allows the pump, whenever the pump's on, it's always running at 100% capacity and filling this tank up. So if you're running an 8 gallon a minute zone, once this cuts down to 40, then the pump kicks on. Now the pump is doing more capacity than the zone needs, so the pump will stay on until it hits 60 PSI. So to recap that, pump turns on when we're down to 40, and it will run and run and run until we get back to 60. Now let's talk about a common scenario. Remember 10 gallons a minute on the pump? Say we have a 10 gallon a minute zone. You've got 4 rotors. All of them have 3 gallon a minute nozzles, right? Very common that happens. Or maybe they were designed with 2 gallons a minute. Rotors have broken, mowers run over them. Maybe somebody gets it replaced. They put a 3 and a 3 and another 3. And then now you're running more than 10 gallons a minute. Well, guess what happens? So this thing runs down to 40. Pump kicks on. The flow that's being required out of here is greater than that of the pump. So this needle will continue to drop, and your rotors in the lawn will continue to die and die and die. So what you want to do to know if you have a zone that is under or over capacity, you need to run your zone until you watch this go down to 40, and then as soon as you hear the click and you know the pump's turned on, now you're watching to see what is the needle doing. Is the needle maintaining at 40? Is it going up from 40, or is it dropping below 40? Now, in case we were watching a minute ago, it still was going up, but we had some rotors that just didn't look good. It's still just not nozzled correctly. So if you're ever wanting to put in a system and you need to know what your flow capacity is, or if you want to make sure all of your zones are going to work, you need to look zone by zone, or at least get this to a situation where you're down to 40 and you hear this click on, because you have to empty the capacity of this expansion tank. The expansion tank will mask pressure issues because it will produce more volume capacity than your pump is able to produce, because it's effectively a infinite capacity divided by the time it's running, friction loss and other things. Because I mean, if you're running 100 gallons a minute, it'll just empty out immediately. So it'll run good for a few seconds. If you're running, you know, I mean, pending friction loss, probably not an accurate number. If you're running 8 gallons a minute, it's going to be really slow. Or 15 and you're above the pump, be really slow, look good for several zones, then your zones in the back won't look as good. So that's the general concept. 40-60 kick on, kick off. Runs just like an air compressor, and it operates your pump relay there to actually send power to turn your 10 GPM pump in the ground on and off, running at 100% capacity at all times. That's how we deal with a well.